What we learned about on Wednesday and Thursday and Friday of last week was about using sine, cosine, and tangent ratios to solve for missing side lengths. So just a little recap, sine, cosine, and tangent buttons on your calculator have all of the ratios stored in them of all the possible angle measures in a right triangle, the acute angle measures at least. So sine button knows all of the ratios of the opposite to the hypotenuse. The cosine button knows all the ratios of the adjacent over the hypotenuse, and the tangent button has all the ratios for the opposite over the adjacent. So we're going to just do two quick questions. You'll see the first one is we're given that one side is 12, given a 90-degree angle there, and we're given another side is x, and we have a 50-degree angle. So when you're given one side and an angle and looking for a side, we're going to use sine, cosine, or tangent. So first thing that I'm going to do is I'm going to label my sides. So I know that this one is my opposite. Let's do something a little bit lighter. Okay, so I know this is my opposite. I know this is my hypotenuse, and this is my adjacent. So I have to decide what I'm going to use. Am I going to use sine, cosine, or tangent? So I look to see what I have. I have my adjacent and my opposite, so that means that I have to use tangent. So I do tangent of 50, because tangent is always of the reference angle, equals opposite over adjacent. Write tangent of 50 over 1 and cross multiply. X equals 12 tangent 50. So I'm going to put that into my calculator, 12 tangent 50, and I get x equals 14.3. So that's my answer. All right, jumping down to number 2, same type of triangle. I have it's a right triangle. I know one angle measure, and I have a side, and I'm looking for a side. So I'm going to label my sides. I've got my hypotenuse, I've got my opposite, and I've got my adjacent. This time I'm going to be using the one that has opposite and hypotenuse. That's my sine. So sine 75 equals the opposite, which is 9, over the hypotenuse, which is x. I'm going to write sine of 75 over 1, and I'm going to cross multiply. I get 9 equals x sine 75. I got to get x by itself, so I'm going to divide both sides by sine 75. Put that into the calculator. 9 divided by sine 75 gives me that, those canceled out, so it gives me 9.32 equals x. All right, so one of the problems that I saw was, on the quiz especially, was people mixing up the special right triangle rules with the Pythagorean theorem. So let's do a little bit of a comparison here between these. When to use Pythagorean theorem. So this one's going to be the when to use row for all of them. We use Pythagorean theorem when we are given two sides. Okay? We use special right triangles when we use them. That's when it's a 30, 60, 90, or a 45, 45, 90, and we're given one side and one angle. But one of those angles has to be 30, 60, okay? And then for sine, cosine, and tangent, it can be any angle measure, but we have to be given one side and one angle. Now, all of these, as of right now, we will add to it later. What are we finding? For Pythagorean theorem, a side. For special right triangles, side. For sine, cosine, and tangent, side. So this is why they get confusing. So as we go along, we're going to be adding to the uses of sine, cosine, and tangent. But for right now, you have to keep straight when to use Pythagorean theorem, when to use special right triangle rules, and when it's okay to use sine, cosine, and tangent. So make sure you answer the questions, and that's it for this video.